Hi, in this video I'm going to be going over how we can create the K-means algorithm using Python and NumPy. I will not be using any other libraries, but I will be using to only visualize Matplotlib. Other than that, we won't be using anything like scikit-learn or anything, so we're going to make it basically from scratch using NumPy um, as we need to store our data and perform some operations on it. Okay, so to get started, I will just open up Visual Studio Code, and I'll just save this file, here. Save it as KMeans. And I'll open up my terminal. Okay, so before we get started with anything, my Python version is as so 3.8.3, and pip list, I think. My version of NumPy is 1.19.2, and just for good measure, my version for Matplotlib is 3.3.2. Okay, so K-means, as a quick intro for people unfamiliar, is a machine learning algorithm used for unsupervised learning, where you're not given any labeled data, and you're just trying to aggregate it. You're trying to find some relationships within the data itself. So you're just creating these clusters. It's a clustering algorithm. And in this video, I'm going to be using only 2 clusters to keep things simple, and 2D data, so we can visualize it nicely on a grid, or like on the Cartesian plane. So for libraries, we're just going to need a few things. So we only need sys for our command line arguments, which we'll do at the end. And for NumPy, we need to import it. And Matplotlib. Oops. So the first thing I'll do is let's just get some data points. You can get it from anywhere. I'm just going to generate it using RNG. So I'll just create a function here called get data, and it can be fed in how many points you want to generate. And we can just get it like this: data equals np.random rand. So we're going to want to generate like the number of points. If I pass in 100, we want 100 points. And we want 2 columns because it's just going to be x and y. So this will generate in total, if we pass in 100 here, it'll be 100 by 2. So it'll be 200 randomly generated numbers from the uniform distribution. And that's it for this for now. Let's just make sure we can visualize this. So we'll return the data. We'll call it here, get data, let's call it 100. And let's quickly throw up some plotting using Matplotlib. So I'll go like this, put a function for plotting the data. And it'll be a scatter plot. We're going to want all of the rows, but only the first column, because that is the x. And we need to pass what the y is, which is the second column, or the first index. but we want all of the rows. And plt.show. This should do it. We should be able to see some stuff pop up now. Okay, let me save this and let's run it. Oh, oops. There we go. Okay, so we have a bunch of data. Let's call this again and see what happens. So you might see that the data shifted around. The points aren't exactly in the same spot. Just for reproducibility, what I'm going to do is introduce a seed so that whenever we call this, it's always going to be giving us the same data points every single time. So we can just adjust this get data thing. And you know what, we can actually leave it optional. So we can go like this, seed equals none. So by default, it'll just generate random points. And let's just handle that case. So if seed is not nothing, meaning we have a seed, then we need to set the seed. Just set it to your favorite number. Mine happens to be 2. Okay. Now if we call this again, it is going to give us this output. Let's take a look at, just so for me it's easier, I'll keep a tab on these 3 points which are really close together. If I call it again, it should give me the same thing. And it did not. Entry.random.seed. All right, because I'm not actually passing it. And, or I should set it here. That's my seed. There we go. Okay, so this string of dots at the bottom, I'll keep an eye on those. And they're the same. So our seed is set. Okay, so this is going to return NumPy array in the shape of xy. Now that we have that, what we need to do next is the actual KMeans. How KMeans works is you basically, if we have 2 clusters, you're going to pick 2 random points out of this data, and you're going to assign those as center points. And each of those points are going to grab the nearest points to themselves and create a cluster out of them. So if a point Z is closer to one of the centers rather than the other, it's going to go in that collection, in that cluster. And that will be the initialization phase. From there on, the centers will move. So once you have those initial clusters, the center of all that data, the mean of it, will be computed, and that will act as a new center. And then the same thing happens. The closest points to those centers will be grabbed and put in those clusters. And this will keep repeating itself until the center does not move anymore and you have reached convergence. So I'll probably reiterate a bunch of this as I go through it, just so it's more clear. But what we're going to want to do next is, so we have these points, but we don't know the centers yet. So we need to initialize some. We have to pick 2 random points and make sure that they act as our centers. So I'm going to do this. I'm going to create centers, and it's going to be we're going to permute these rows and just pick the top 2. That's one way you can do it. There's other ways you can do it. Permutation. So this will permute the rows but we only want the top two because we only want 2 clusters. So we're just gonna slice it like this. That will grab our centers. So when we have our centers, we have to do the compute. We have to compute the distance, and that's just done using Pythagoras. So the distance formula can be used. I will make a function for that. So we could call it maybe calc dist data centers. And I'm going to make a copy, and you'll see why in a minute. I'll just call this data with dists is a copy of the data. And for each of our centers, so we have 2 centers since we're doing a cluster of 2, so this will be iterated through twice. So I'm just getting how many rows are in there. There's going to be 2 in there because there's 2 centers. We're going to compute the distance. So this is done using the distance formula, and we can use some NumPy operations. So the distance is calculated as the square root of the difference of the data and the centers, like that specific center, to the power of 2. And we need to sum those. So what this is essentially doing is it's a squared plus b squared equals c squared. So c is the square root of a squared, which is going to be it's going to be like the x and y's. So the x and the y, a squared, and then plus b squared. So the distance formula is just given by Pythagoras. Sorry, I was reading my notes. Just wanted to make sure I did not mess this up. But it's the square root of a squared plus b squared, and that gives you the distance. And we're doing it. We could do this in maybe an easier to read way if you're not familiar with vectorization. Like we could just use loops to go through each of the rows, and it might be clearer to some people. But typically you want to stick to vectorization. It's a lot more efficient when you're doing ML work. So it's good to get accustomed to it, but I know it can be kind of strange looking at it at first. So this is going to be our distance, and what I want to do is, right now we have x and y in data. The reason why I copied this is because I want to actually add the distance. I want data with the dists to be x, y, d1, and d2. Just keep it all in one sort of container. So what I'm going to do is I need to concatenate this new distance column onto the end of what right now is just data. So to do that, we can use column stack. Give it a tuple. Okay, and this will iterate twice. We're going to attach a column for each iteration. And what we're going to get back is the data with dists. And the shape of this, or the columns in this, will be x, y, d1, D2, and so on if we had more clusters, but just D2 for now. Okay, so now that we have a way to calculate the distance, we can just call it, so data with dist equals dist data centers. Okay, we're almost at a point where we can plot and make sure that we're on the right page here. What we need to do next is get the clusters. So we have these distances. What we want to do is go through each of these two distances, see which one is smaller, and put that into its own cluster. So for all the rows where D1 is smaller than D2, we want it in one cluster, and the opposite. So we can do this in, let's say, yeah, may as well throw in a different function. Def get clusters. And we just need data with this because it has everything we need in it. And the way we're going to do this is through masking. So this is going to be all of the rows where the value at the second column, which is D1, because 0, 1, 2, 3, is less than the value at D2, or sorry, yeah, at D2, which is column 3. And that's a cluster 1 mask. Similarly, we're going to do a cluster 2 mask, where these are flipped. And just in case there's some which are equal, I'll just throw it in the cluster 2 mask. Oops. I'll just run the cluster 2 mask. And what we can do is return the mask applied to the dataset, which will separate out these rows for us. Data with dist. We want all the rows which fall under cluster 1 mask, and all the rows which fall under the cluster 2 mask. And every column for those rows. Okay, this will grab us our clusters. And we are ready to print to the screen, make sure we're on the right page. We'll have to add a little bit of plotting data, but the trickiest part, I think, is done. So we can get cluster 1 and cluster 2 using our new method. Get clusters. So we want to visualize these clusters and the centers too. What we can do is we add some. Yeah, we'll definitely need a method to plot. Clusters, and we're going to take in each cluster and the centers. These are all going to be scatter plots, so I can probably yank this here. Okay, so we're going to plot cluster 1. We're going to plot cluster 2, or sorry, cluster 1, the X and Y. And I'm going to add a color to this so we can differentiate them. So for this one, I'll just put blue. And I need to copy this. So we can do the same for cluster 2. Make it red. And I want to show where the centers are different than these. If I leave it the way it is, they're just going to be like blue or red. So, at least to start, what I will do is, yeah, we can just plot this way. So we can grab the first center. Oops. This grabs the first center, and we want the x value of it. This grabs, and over here we want the y value of the first center. Centers. This should work. And I'll make it purple. Should be easy to stand out. Similarly, for the other center, could have definitely thrown this into a loop. Might have been better, but it's okay. It's only 2. Okay, so this should plot what we need, and plt.show. Cross our fingers and hope it works. So these are just the initial clusters that we have after each of the centers are pulling in their closest points. We still have to do the kind of like a recalibration part where we calculate the mean and recalculate the centers, and again we recalculate the clusters. But for now, let's see kind of where our starting point is at. So this will plot data, and let me do this: plot clusters. Cluster 1, cluster 2, centers. Okay. So this is the original data, and here we go. So let me check this again. Looks like this point gets chosen. Yeah. So 2 random points were chosen, and the closest, like all the other points, whichever one they're closer to, they're going to fall into that cluster. So this one way out here is closer to this purple one, so it becomes blue. And this one gets all the reds that are below. And then over here in the middle, you can see there's like, it kind of goes a little bit back and forth, but generally it's sliced up pretty nicely. So what we need to do is add the actual movement of these centers and recalibration. So this, in the next step, what I would expect is this purple dot will move probably over here, because that's like the mean of this blue space. And then it'll probably split like down here or something like that. So we need to do that. Okay, so it's the operations to calculate the mean are fairly straightforward. I know the distance one can kind of look a little strange, but the mean one I think should make a lot of sense. I'll put it over here. Calc centers. So we have the 2 clusters, cluster 1, cluster 2. And the first center, that is the center of cluster 1, is going to be simply the mean. This is provided by NumPy. It's the equivalent of going through the x's and y's, adding them all up and then dividing by the number of data points. Again, we could loop through, or we could do this way. And so the clusters, remember, they are a subset of data with dists, which is x, y, distance 1, distance 2. The centers, we only care about x and y. So again, we can chop this off using slicing, where we only get the x and y because we don't care about anything else. And similarly for center 2. just as so. And that's it. I will put them in a NumPy array just to keep things consistent and not as a tuple here. Center 1, center 2. Great, there we go. We have everything we need now to construct the engine, I guess, of this algorithm now. So rather than writing more down here, I'm going to kind of properly make a main method, and then we can call it from the command line. So let's go like main. I'm going to provide it. We want to be able to provide the number of points we want to generate, as well as the seed, which we'll keep optional again. I can probably reuse some of this. So we're going to grab the data points. That's how many points we want. The seed is whatever we provide in. We're going to want to keep track of the current centers and the previous centers, because the way this thing stops is that those two things are equivalent. So on our first step, we're just kind of grabbing random ones. So I'm just going to call this current centers. And we have no previous ones, so let me go like this. None. And let's plot the data before we start anything, just so it's easier to visualize, or it's nicer to visualize. I'll put a print statement in here. We'll do something like plotting data, and we will plot the data. Okay, time to start the loop, which will keep going until current and previous are the same. So while they are not the same, you want to keep this loop going. So to check for equivalence, I'll use array equal, which will compare the elements and the sizes. And it'll handle the none. It won't crash on that. Can I reuse some of this? I don't know, but we'll try. Okay, so data with dists is data and curve centers. Cluster 1, cluster 2. This looks good to me. We will plot the intermediates of the current centers. So let me do this print. This will just help me to know when I should click the little X on the Matplotlib showing up and kind of where I'm at. So we'll do like plotting intermediate clusters. All right. And to continue on in the loop, we will, or rather, so we are actually progressing, we need to set previous centers to the current center, and we need to call our recalculation for the centers. So current centers becomes that recalculation. Centers. Stir 1, stir 2. And that should be it. Oh, right, I should plot the kind of final output. So we'll go like plotting final clusters. Just do this right here. I'm too lazy to type. Okay. We'll just set up a quick hook for the main. So we'll go like name like to pass some command line arguments to set these two things. So we'll leave it as an option. So if they have provided a seed, so the length of this should be 3, then just put a print statement verifying that's what they wanted. Starting KMeans with a seed. And we can call that our main. We'll have to do parsing because these are going to be coming in as strings, so I'll parse them into ints. The first command line argument is going to be the number of points, and that is not going to be optional. I'm not putting any error handling on this. And then since we have a seed, we will provide it. And else, so if this is 2, then there's no seed provided. So we'll go like this. Starting KMeans without a seed. And we're only going to be providing the count. Okay, that should do it. Save and let's see what happens. So this will crash because I'm not providing the command line stuff. Let's do 100 point generated and 2 as the seed because I like the number 2. Okay, so this is our original. So plotting data. Here is the original centers, so intermittent clusters, and let's see how it moves. So you can see it's kind of moving towards the center. At first it'll jump a lot and then it'll kind of slow down a little bit and keep going until it reaches a happy sort of area. And this is the final cluster that we have reached. So these are the 2 clusters created. This data is very uniform, so what I'm going to do is I'm going to tweak it a little bit so we can better see how this thing really operates. Let's see. To do this, I'm going to just push about half the data in one direction. Let's see. I'll come back up here to where we're getting our data. What I'll do is about half the points, I'm going to add like 0.75 to the x and the y. So it'll shift it to the right and up and to the right. So to do that, I'll have a variable like stop adding. It's like it's an index, but I guess it's the index where you stop adding. And it'll be the number of points minus 1 and the integer division divided by 2. So it's about half the points. And what we'll do is to our data, we will just change it a little bit. So from 0 to row this exclusive and all columns. We're going to add 0.75. This should be good enough to provide us with a little bit of a separation there. Okay, let's see. Yeah, so now these two are kind of separated. What I would hope is that this box is in one cluster and this is in the other. What could happen is that you kind of get your random pick, because your initial points are really important that are chosen, and those can be optimized in other ways, which I will cover in the video. But right now, you could, in theory, have 2 points like this one, and then they kind of split each box. But we'll see what happens. So that's not what happened, luckily. So this should actually take over this part of the graph. And that's what it looks like it's doing. So this is kind of like the cluster which a human being would probably kind of come up with. Maybe these would be separated like a little bit more, like 50-50 and not just all in the blue. And we can run this. I didn't really test this without a seed. Hopefully it'll work. So no seed. So it should give us new points. Looks like it did. And we could try it with like 250 data points. More data there. And that was a quick migration to the bottom box. And that is KMeans.